Hello everyone. In this session, I am going to explain or I am going to discuss regarding a model which analyzes shock waves. Then we will move on to define some conservation laws, that is law of conservation of energy, law of conservation of mass and law of conservation of momentum. Then I will explain about a shock tube particularly called as Reddy shock tube, which was developed by K.P. Reddy, which is a handheld shock tube. We will discuss regarding the applications of the shock tube. Now let us start with the model which I said, which analyzes the shock waves, which is called as a control volume. Now what is this mean by control volume and what it does? Now this is a pictorial representation of what we call as a control volume or pictorial representation of a shock wave. Now control volume is a model on the basis of which the shock waves are analyzed. So I repeat, control volume is a model on the basis of which shock waves are analyzed. It is an imaginary envelope which envelopes the shock front, within which there is sharp increase in temperature, pressure as well as density of that compressed medium. Now as you can see, this is a shock wave. Or it is a shock front part of a shock wave, and surrounding the shock wave you have an imaginary envelope which we call it as a control volume of thickness of about 1 micrometer, within which the whole area is compressed and there is sharp increase in temperature, pressure as well as the density. And if you consider the whole control volume has been divided into two parts. One is the pre-shock side and one is the post-shock side, and the whole thickness is about 1 micrometer. Now in the pre-shock side, let ρ1 be the density, u1 be the flow velocity, t1 is the temperature, p1 is the pressure and h1 is the enthalpy in the pre-shock side. And in the post-shock side, ρ2 is the density, u2 is the flow velocity, t2 is the temperature and p2 is the pressure, as h2 is the enthalpy of that medium in which the shock wave or shock front is propagating. Then using these parameters, one can develop certain equations based on the laws of conservation of the mass, energy as well as the momentum. So in simple, it is an imaginary envelope that surrounds the shock front within which there is a sharp increase in temperature and density in a compressed medium. It is a one-dimensional confinement medium with two surfaces pre-shock and post-shock. First one, it is assumed that the heat energy remains constant the energy transfer is adiabatic and follows Rankine-Huguenot equations. And third one, it follows laws of conservation of mass momentum and energy. So these are the three properties of the model of control volume. So it is assumed that the heat energy remains constant, and second is the energy transfer is an adiabatic and follows the Rankine-Huguenot equations, and third one is it follows the laws of conservation of mass, energy and momentum. So basically it's a brief explanation regarding a simple model which analyzes the shock wave, and it is an imaginary envelope within which there is a large increase in pressure, temperature as well as the density in the compressed medium. We will start with the law of conservation of mass. So what does the law of conservation of mass says? So whenever we are considering the conservation laws, we have to consider certain systems. So we know that we have a closed system, we have an open system, we have an isolated system. So based on the conservation of the corresponding physical quantities, we have to consider the corresponding system. So what does the law of conservation of mass says? In any isolated system, the total mass of the system unchanged irrespective of any physical or chemical changes which occur in the system. So, law of conservation of mass says that if you consider an isolated system, the total mass of that isolated system, it remains unchanged even though any physical or chemical activities which may take place inside the system. So, the equation for this is given by rho 1 U1 is equal to rho 2 U2, where rho 1 is the density and U is the flow velocity in the pre-shock side, and rho 2 is the density and U2 is the velocity in the post-shock side of a shock wave. Next, we will move on to the law of conservation of momentum. So, what does the law of conservation of momentum states? Now, law of conservation of momentum can be stated in two ways. Either it can be said that in a closed system, the total momentum of the system remains constant, or else it can be also explained in the isolated system. When two objects collide, in an isolated system, the momentum of those objects before collision is equal to momentum of objects after collision. So, if you consider an isolated system and let us say there are two objects, and if those two objects collide, then the momentum of those two objects before collision should be equal to the momentum of those two objects after collision. P1 plus rho 1 U1 square is equal to P2 plus rho 2 U2 square. So, in the left hand side the parameters are in the pre-shock side of a shock wave, and right hand side the parameters are in the post-shock side of a shock wave, where P1 is the pressure, rho 1 is the density and U1 is the flow velocity, and similarly P2 is the pressure, rho 2 is the density and U2 is the flow velocity in the pre-shock side as well as the pro-shock side respectively. Now, these are the conservation of mass as well as the conservation of the momentum. Similarly, there is third conservation law, that is law of conservation of energy. The law of conservation of energy states that the total energy of a closed system remains constant and is independent of any changes occurring within the system So, if you consider a closed system, the total energy of that closed system remains constant even though any changes may occur in that system. Means either the changes can be physical changes or else the changes can be chemical changes. So, that is what the law of conservation of energy says. The equation based on the parameters is given by H1 plus U1 square by 2 is equal to H2 plus U2 square by 2. Again, the parameters on the left hand side of the equations are on the pre-shock side, and parameters of the right hand side of the equation are on the post-shock side of a shock wave. H1 is the where H1 and H2 is the enthalpy, and U1 as well as U2 is the flow velocity. Next, we will discuss regarding a shock tube. In particular, it is called as the Reddy shock tube developed by K.P. Reddy. It is a hand-held piston driven shock tube which can be operated by using the mechanical energy. Block diagram of a Reddy shock tube. So, Reddy shock tube can be defined as it is a hand-held piston driven shock tube which can be operated using the human mechanical energy. Reddy shock tube consists of a cylindrical steel tube of length 1 meter and diameter 30 millimeter. It is a cylindrical steel tube which has a length of 1 meter and diameter of 30 millimeter. The whole cylindrical steel tube is divided into two sections. One is called as driver section and second one is called as driven section. And the driver section as well as the driven section is separated by diaphragm. The one end of the driver section is fitted with a piston and other end of the driven section is sealed with the steel tube. Now, inside the driver section you have what is called as driver gas, which is kept at a comparatively higher pressure in order to make the gas compress, and inside the driven section we have what is called as the test gas, for which we have to find out the pressure and temperature. And the driver section we call it, the end has the upstream end, and the driven section we call the end as the downstream end. Now, at the end of the driver section we have fixed digital pressure gauge which is very near to the diaphragm, and at the end of the driven section near the downstream end there are two piezoelectric sensors fitted apart of about distance of 70 millimeter. Now, the test gas is filled in the driven section by using a nozzle. Through the driven section is completely sealed once the test gas is filled inside the driven section. So, how does the Reddy shock tube work? In the driver section, the piston is pushed inside the driver section by using the hand very hardly until the diaphragm ruptures in the upstream end. Now, the diaphragm ruptures because of the compression of air or compression of gas inside the driver section. As soon as the diaphragm ruptures, the driver gas rushes into the driven section and it pushes the test gas to the downstream end of the Reddy shock tube. And because of this, there is an increase in pressure and temperature leading to the creation of the shock waves, which is called as the primary shock wave. Now, once the test gas collides with the wall of the downstream end, it gets reflected back, and once it gets reflected back, again there is a change in pressure and temperature of the test gas, which leads to the creation of the secondary shock wave. This secondary shock wave again traverses back towards the driver section. But during the rupturing of the diaphragm, there is another wave which is called as expansion wave which is created. This expansion wave also travels back towards from the piston towards the middle of the diaphragm, and the expansion wave as well as the shock wave, secondary shock wave is created, they cancel each other. Now, because of the rupturing of the diaphragm, the primary as well as the primary shock waves are created, and because of the collision of the reflection back of the test gas, the secondary shock waves are created. The pressure as well as the temperature of the primary shock wave as well as the secondary shock wave is measured by the digital pressure gauge near the driver section and by the piezoelectric sensors S1 and S2 near the driven section. Once the pressure and temperature of the gases around the primary shock wave as well as the secondary shock waves are recorded by the CRO, the arrival time of the primary shock wave as well as the secondary shock wave are recorded by the CRO. By using the pressure, data of pressure, temperature as well as arrival time, the parameters like the Mach number can be calculated. So, this is how a Reddy shock tube works. First one is cell information. Using the shock wave, the data can be inserted into the cell or the DNA, any external DNA can be inserted into the cell or any kind of cell, so that the information of the cell can be changed or the information of the cell can be even read. Second one is wood preservation. In the conventional method of wood preservation, the chemicals has to be injected inside the wood and it takes a lot of time. By using the shock waves, the chemical preservatives can be pushed inside the interior of the wood, so that the time required for the chemical insertion is comparatively less when compared to the conservative techniques. Now, in the case of pencil industry, in order to manufacture the pencil, the wood which is used, in those woods the injection of the liquids or the injection of the certain chemical preservatives can be done instantaneously inside the wood which is used to manufacture the pencil, and because of which the drying time of the manufacturing wood is comparatively less in the case of when compared to the conservative techniques in the case of the pencil industry. So, in order to dry the wood which is used for the manufacturing of the pencil, the shock waves are used. Shock waves are used in the technique called as extracorporeal lithotripsy, wherein the kidney stone is powdered inside the human body using the shock waves. The shock waves are sent into the human body. So, in order to powder the kidney stone, so that the kidney stones can be removed through the natural process. Fifth one is a gas dynamic study. Now, as we know that whenever the shock wave is created, various high temperatures, high pressure and high density is created. Now, in order to study the high temperatures or high pressure as well as high density of the corresponding gases, these shock waves can be used. So, that is why it is called as the gas dynamic study. Now, sixth one is needleless drug delivery. Now, in order to deliver a drug inside the human body, usually the conventional methods is in order to use needles. Now, using the shock tube, the drug which has to be administered, or the drug which has to be delivered inside the human body can be delivered without using any needles through the surface of the skin. So, through the surface of the skin pores, the shock waves can be used in order to deliver the drugs inside the human body. Now, seventh one is treatment of the dry borewells. Now, the borewells usually will be dry because of some kind of blockage of the water source. Using a shock tube, the shock waves can be sent inside the dry borewells, and any blockage can be removed because of the strength of the shock wave. And the blockage, once the blockage is removed, the source of the water can be brought back to the dry borewells. So, this is how the shock waves can be used in the application purposes. These are some of the very important applications of the shock waves. One is the cell information, in order to inject the DNA in order to change the information of the cell, in order to preserve the wood. When compared to the conventional methods, the shock waves, using the use of the shock waves, it takes much less time. In the case of pencil industry, in order to dry the wood, which also takes much less time when compared to the conventional methods. For in the case of kidney stone treatment, where the shock waves can be sent from the outer of the body, so that the kidney stones can be powdered inside the body. In the case of gas dynamic study, because as the shock waves are created, a huge increase in pressure, temperature, as well as the density of the gas around it takes place, which can be used to study the dynamics of the corresponding gases. In the case of needleless drug delivery, where the drugs can be delivered inside the human body without using any needle, and treatment of the dry borewells, where the dry borewells blockage can be removed using the shock waves. So, these are some of the application of the shock waves.